This lesson is part 1 of 2 on how to solve inequalities. The first thing that we want to look at when we're looking at inequalities is identifying the solutions to the inequality. Now, in this problem, we're given a replacement set. We worked with replacement sets at the beginning of this course in solving equations. We wanted to figure out, which one makes the equation true. Well, it's the same thing here now. We just want to figure out which one or ones make the inequality true. So let's look at the first one. -8. Is -8 greater than -5? No, -8 is lower than -5. -5.01, is that greater than -5? No, it's not. If you're having trouble with this or trouble picturing it, draw the number line out. Put a -5 right there. You have to figure out -8's down here, so it's not greater than. -5.01 is right here, so it's not greater than. -5, is -5 greater than -5? No, it's equal to. So that's not a solution. -4.8 would be right here. So yes, this is a solution. 0, is 0 greater than -5? Yes. Is 4 greater than -5? Yes, it is. So the solution would be -4.8, 0, and 4. Whenever you're working with equations and using a replacement set, there is generally only one, especially in our case at this level of math, there is one solution. When you're working with an inequality, because more than one of the values in the replacement set could be greater than -5, you can have more than one answer very easily. So what you want to do, your solutions will go inside parentheses. You can put them in brackets, whichever one you want to use. Brackets and parentheses basically mean the same thing whenever it comes to math. Okay, here's the same exact situation. X is less than -1, so we have to identify all of the numbers in the replacement set that are less than -1. And again, if it helps you to draw out your number line, go right ahead and do so. You have 0 here, you have -1 here, so we want to identify anything that is lower than -1. -2 is down here, so -2 is less than that. -1.6 would be about right here. It is less than -1. -1 is less than -1. No, it's not. It is equal to. 0 is less than -1. No. 0.5 is less than -1. No, it is not. So our solution is -2 and -1.6. And that is our answer. Now in this problem we have x is greater than or equal to 4. So in this case, whenever it comes to the 4, is 4 greater than or equal to 4? Yes, it is. Yes, it is, because the equal to part makes it a true statement. So we have to find numbers or integers in the replacement set that are greater than or equal to 4. So 4 applies to that. 4.2 is greater than 4. 5 is greater than 4. These numbers are all less than 4. They're not equal to, or they are less than 4, so they are not part of the solution set. Our solution set is 4, 4.2, and 5. Now, whenever it comes to solving inequalities, there are two things to remember. It is the same process as solving equations, you just have the inequality signs instead of the equal sign. So you're going to use the same processes that we've learned for solving equations, which is great because now you don't have to learn a new process. Now, the second thing that you have to keep in mind, and we're going to see a couple of examples of this, if you multiply or divide both sides of the inequality by a negative number, you have to switch the inequality sign. For example, if you had, let me show you a quick example of this. If you had negative 3x is greater than 9, your inverse operation is to divide both sides by negative 3. Whenever you do this, you have divided both sides by a negative number. So if you multiply or divide both sides by a negative number, you've got to switch this sign. So this sign, instead of saying greater than, it's going to say less than. And you do everything else the same. Negative 3 divided by negative 3 is 1. You're left with x is less than negative 3. 9 divided by negative 3 is negative 3. So if you multiply or divide both sides by a negative, this has nothing to do with addition and subtraction. This is only multiplication and division. Another example would be x over negative 2 is less than 8. My inverse operation would be to multiply both sides by negative 2. So I have negative 2 divided by negative 2 is 1. Now I'm left with x. Now this sign is going to change to greater than negative 16. So you do everything else the same, exactly the same. It's just if you multiply or divide by a negative number, you have to switch that sign. Okay, so here we have our first inequality to solve. 4x minus 15 is less than 17. What is my first inverse operation? You want to remember that this is exactly like solving equations. So you're going to get rid of your addition and subtraction first. So you're going to add 15 to both sides. Minus 15 plus 15 is 0. So you're left with 4x over here is less than 17 plus 15 is 32. So everything is the same. Remember to keep that inequality sign. I sometimes find students, they change it accidentally to an equal sign as they solve it, but you can't do that. You've got to keep that inequality sign there. What's my next inverse operation? I have x multiplied by 4. I'm going to divide both sides by 4, and I am left with 4 divided by 4 is 1 times x is less than 32 divided by 4 is 8. Notice that I was working with all positives here. I divided by a positive. This sign stays the same. You can see it stayed the same the entire way through, and it will always remain the same unless you multiply or divide by a negative number. That's the only time that you will change that sign. Now this time x is on the other side of the inequality sign, and that is just fine. Just keep everything where it's at. Our first inverse operation, we want to get rid of this addition here. That's the first thing you always want to get rid of. So what's happening to x? It's added to 4. So we want to subtract 4 from both sides. 4 minus 4 is 0. You're left with 2x over here. We're going to keep that same sign there. Same less than sign. Negative 8 minus 4 plus negative 4 would be negative 12. Now we have to look at what is our next inverse operation. We have x multiplied by 2, and I hope that you're figuring out that this really is the same exact process as solving equations. X is multiplied by 2. We want to divide both sides by 2. 2 divided by 2 is 1. You're left with x over here is less or is greater than negative 6 over here. So negative 6 is less than x, or x is greater than negative 6. You could write it like that as well. Remember, if you switch these around, you got to switch that sign around. You've got to read it frontwards or backwards. Okay, now something that I want to point out here is that I did not switch this sign. Even though I have a negative over here, the sign switches only for the inverse operation. If this 2 would have been negative, then I would have switched the sign. But since this 2 is positive, this sign stays the same. All right, now we have a fraction, and that's okay. It's always made more complicated than it needs to be. Don't make it any more complicated. It's always the same. It's inverse operations. So we have x divided by negative 6 is greater than or equal to negative 2. Okay, we've got a few things going on here. We don't always see this division here, and there's a lot of negatives, so we got to pay attention to what's happening. The first thing you want to concentrate on is what is the inverse operation of what's going on. X is divided by negative 6, so we want to multiply both sides by negative 6. We have negative 6 divided by negative 6 is 1. You're left with x over here. X over here, and we have 12 over here. Our sign is going to switch. Our sign is going to switch because we multiplied both sides by a negative. My inverse operation was to multiply by a negative. So if your inverse operation is to multiply or divide by a negative, your sign switches. So our final answer is x is less than or equal to 12. X divided by 4 minus 5 is less than negative 1. The first inverse operation needs to involve getting rid of that subtraction. You always get rid of your addition and subtraction first, if there is any. So we have minus 5. We want to add 5 to both sides. Minus 5 plus 5 is 0, so you're left with x divided by 4 is less than negative 1 plus 5 gives us 4. Now, let's see what we have going on here. We have x divided by 4. What is the opposite or the inverse operation? We want to multiply both sides by 4. 4 divided by 4 is 1. You're left with x over here is less than 16. Notice my sign stayed the same the entire way through. I was working with positives here. My last inverse operation, or an inverse operation, involved multiplying by a positive, so that sign stays the same.